Joe, our service manager, is having an after-hours session with Larry, a new write-up man. The subject is Torqueflite diagnosis, and the discussion should be real interesting. Let's listen in.
Larry, it's as simple as this. Our procedure on Torqueflite work in this shop is diagnosis before teardown. In other words, we check for the obvious and road test the car before we open up a transmission. You see, the customer's complaint may be misleading, so it's wise to check it out for yourself. Anyway, you should know how the transmission acts before any work is done, so you can tell if the original trouble is corrected. For example, if you get a car with an erratic shifting condition, one possible cause is a short throttle linkage setting. However, if the short linkage setting caused severe front clutch wear, the condition may still be there after adjustment.
And don't forget that poor engine performance can also make a transmission act up. So don't get started on the wrong track. You're off to a good beginning, Joe. I'll bet Larry and lots of other good men would like to hear how you diagnose Torqueflite jobs. How about it?
Well, okay, Tech, you're twisting my arm. I was just going to mention the importance of fishing for clues when talking to a customer. Sometimes you find that the trouble started after some other work was done on the car, and the cause can narrow down to a simple linkage adjustment.
Thanks for the reminder, Joe, but what's the procedure if you have to start from scratch?
It's the old familiar process of elimination, Larry. First, you check the simple, basic things like the level and condition of the fluid and the linkage adjustment. Then, if these are okay, you make a road test, and if necessary, follow up with pressure tests in the shop.
Let's see if I've got the dipstick routine right. The fluid level is okay when it's between the full and add 1 pint marks with the engine at idle speed, the transmission at operating temperature, and the selector in neutral. I understand the need for fluid warm-up, but what's so special about being in neutral?
The torque converter fills more slowly in park position, so we use neutral to make sure that the dipstick check is accurate. Also, after a drain and refill, we shift through all the ranges so the hydraulic circuits will be full when the fluid level is checked.
In other words, make sure everything is in normal condition before checking the dipstick. Say, why is correct fluid level so important?
Well, low fluid level appears as a possible cause of 10 out of the 20 conditions covered in the Torqueflite diagnosis section of the service manual. Low fluid level can cause a variety of transmission conditions because it allows the pump to take in air along with the fluid. Air bubbles make the fluid spongy, and this results in low system pressure or slow pressure buildup. The effects of air bubbles in the fluid show up in delayed clutch engagement when you shift into drive or reverse and in slipping upshifts. Air in the system can also cause pump whine and governor buzz, but worse than these, slipping, which results from low fluid level, causes overheating and severe wear of clutches and bands. Low fluid level can also starve the transmission lubricating system, causing other parts to wear out rapidly. Be sure to check for leaks if the level is low. Now, in the opposite direction, when the fluid level is too high, the gears can churn up foam and cause the same conditions you get with low fluid level. In either case, the air bubbles and high heat can cause the fluid to form varnish. A high level can also result in fluid escaping at the vent, where it may be mistaken for a leak.
All that just from bubbles? What's the story on changing the transmission fluid?
In normal use, the original fluid should not need changing during the life of the car. But for trailer towing or in taxi cab, police, or other heavy-duty service, the fluid and filters should be changed as specified in the service manual.
And don't forget to check the condition of the fluid as well as the level. When the fluid is discolored and smells burned, overheating due to severe operating conditions can be the cause. If this condition is spotted early and the fluid contains no foreign particles, a fluid and filter change may be all that's needed.
Good points, Tech. But when the fluid is dark, burned, and full of metal or friction material particles, it usually calls for a complete overhaul. Be sure to examine the fluid closely, and if there's any doubt, drain out a sample for a double check.
What about varnish and sludge?
Varnish is caused by overheating and should be suspected when the dipstick does not wipe clean. You can confirm this condition by visual inspection after the pan is dropped. Sludge is caused by water, glycol, or other contaminants.
If there is only a light coating of varnish, a fluid and filter change may be all that's required, especially if there have been no operational problems. A heavy coating of varnish or sludge calls for a complete teardown and clean-out. Any good degreaser will remove the varnish and sludge.
When you write up a repair order for a transmission clean-out, it must include the torque converter and the transmission cooler lines. How about coolant contamination, Joe?
Engine coolant or plain water turns transmission fluid milky, swells seals, and softens friction material. If the dipstick shows this condition, you'll probably find the leak at the cooler unit in the radiator. The transmission, of course, must be completely reconditioned.
We can wrap up the story on fluid with a reminder to use only Chrysler-approved fluid labeled Dexron type when adding to or refilling a transmission. Stay away from type F fluid because it causes harsh shifting in a Torqueflite.
Okay, let's hold up a minute while I review the dipstick checks. Fluid level should be between the full and add 1 pint marks. Low fluid level admits air, which can cause delayed engagement, slipping, overheating, or noise. High fluid level causes foam, fluid loss at the vent, and can form varnish. Along with the level, we also check for discolored fluid and signs of varnish. Dark fluid with a burn and smell indicates overheating and worn friction material. Milky fluid indicates a coolant leak, and varnish deposits make the dipstick hard to wipe clean. Okay, Joe?
You're in, Larry. Now, following the fluid checks, selector linkage and throttle linkage adjustment should be checked next. This should be done before road testing to detect improper linkage settings as possible causes of poor transmission operation. The point to remember is that the basic positions of the manual and throttle valves depend on their linkage settings. For example, if improper selector linkage adjustment displaces the manual valve, the car may creep in neutral. In addition, the starter may not operate in neutral or park, and the parking sprag may not hold. Here's what happens. In neutral, the selector lever detent should position the manual valve to cut off pressure to the drive and reverse ports in the valve body. If the linkage is not properly adjusted, it positions the valve off-center, opening one of the ports to line pressure, which causes creeping. In some cases, a small variation in the linkage setting can displace the valve enough to produce only partial clutch engagement, which allows slipping without causing the car to creep. When this condition continues uncorrected, the friction material will wear rapidly. Fortunately, normal operation of the neutral safety switch gives you a quick check of the selector linkage adjustment. With the engine stopped, move the selector lever slowly until it clicks into the park notch on the position gate. If the starter will operate at this point, the park position is okay. Next, move the selector lever slowly toward neutral and stop when the neutral detent bottoms. If the starter will also operate at this point, it indicates that the selector linkage is properly adjusted. Another quick way to check selector linkage adjustment is to note how far the lever can be moved upward beyond the neutral detent point and downward beyond the drive detent point. If the linkage adjustment is correct, the additional movement beyond the detents to the gate stops should be nearly the same.
Okay, Joe? Now how about the throttle linkage?
Well, here again, the linkage setting determines the position and operation of a control valve. But in this case, the results of improper adjustment show up in the shift quality. You see, when the length of the throttle linkage is too short, the throttle valve opens less than normal, so throttle pressure is lower than it should be in relation to the carburetor throttle opening. As a result, upshifting tends to be early, and you may get an engine speed flare-up during the 2-3 upshift. If there's an engine speed flare-up on a very light acceleration upshift, but no flare-up under heavier pedal pressure, it's a tip-off that the throttle linkage is set too short. In some cases, short linkage will prevent full throttle kickdown. Now, in the opposite direction, throttle linkage that is extended or set too long opens the throttle valve too far. This excessive valve opening raises throttle pressure higher than necessary, so upshifts are delayed and harsh. It also makes part throttle kickdown operation very sensitive.
Okay, Joe, right about here we're running out of sound. So take it easy while someone flips the record.
Always remember that throttle linkage adjustment is critical, especially with our current Torqueflites. In fact, when checking the adjustment, we now use a special throttle lever holding tool to eliminate linkage free play error. Along with the throttle linkage, we must also consider engine performance. If the engine is not putting out, the gas pedal must be pushed down farther than normal to make up for the power loss. When the pedal moves farther than normal, you get the delayed and harsh upshifting that is typical of an overlong throttle linkage setting, even though the linkage is set correctly.
All right, Joe. Before we go on, check me out on linkage adjustment high points. The selector linkage adjustment affects manual valve alignment. If the linkage setting is off, the car may creep when in neutral. The starter may not operate in neutral or in park position, and the parking sprag may not hold. Compared to this, throttle linkage adjustment affects shift quality. When the linkage is set too short, upshifting is early. Engine speed may flare up on the 2-3 upshift, and there may be no full throttle kickdown response. In the opposite direction, when the throttle linkage is set too long, the upshifts are delayed and harsh. With this linkage setting, you'll also notice that part throttle kickdown operation is very sensitive. How's that, Joe? Did I miss anything?
Nope, you touched all the bases. Now, if time is short, you can check the throttle linkage setting by noting shift quality during your road test. If you notice any of the erratic shifting symptoms we just covered, you'd better have the linkage setting checked and adjusted before you continue.
Let's assume that the linkages are okay. What else do you check on the road test?
Well, I operate the transmission in each selector position to check for any variation in shifting. I also note the upshift and downshift speeds. The main thing I check for is slipping or engine speed flare-up. You see, slipping or flare-up in any gear usually means clutch, band, or overrunning clutch trouble, and reconditioning is the usual answer. However, in some cases, flare-up during a kickdown is caused by a loose kickdown band, which may only require adjustment.
Okay, but slipping is slipping. How do you tell clutches from bands on a road test?
By comparing the action in all the selector ranges. When only one clutch or band slips, it's fairly easy to pick out because the clutch engagement and band application combinations are different in each range. You can refer to the chart in the service manual for a detailed list of the clutch and band combinations at the different stages of operation. But for our purposes here, you'll probably remember them easier from this simplified chart. But first, let's briefly review the normal shifting sequence. In D position, the car gets underway in breakaway low, and then at appropriate speeds, the transmission upshifts to second and direct drive. Number 2 position follows the same pattern, but upshifts only to second. Number 1 position is limited to low gear. Now, when the selector is in D or position 2, the rear clutch applies. The overrunning clutch holds during acceleration, but releases on deceleration. In other words, there's no engine braking in breakaway low. However, in position 1, the transmission is locked in low gear. Again, the rear clutch engages. But here, the low and reverse band applies and takes over from the overrunning clutch. Unlike breakaway low, this position provides low gear both for acceleration and engine braking.
I don't get it. Why do they use the overrunning clutch in the D and 2 positions, and then go to the low and reverse band in position 1?
It's for smoother shifting, Larry. The overrunning clutch is used because band-to-band shifts between low and second would be hard to synchronize and could be harsh. Tell us what happens, Joe.
In a normal 1-2 upshift, the overrunning clutch simply overruns when the kickdown band applies to cause the shift. After a closed throttle downshift, the overrunning clutch coasts until the car is accelerated again.
Okay, but how does all that apply to road testing?
It shows you how to pick out the cause of slipping by the process of elimination. On the chart, you'll see that the rear clutch is engaged in both the D and number 1 positions. If you get slipping in breakaway low as well as in position 1, the rear clutch must be the cause. However, if there is slipping only in breakaway low but not in position 1, the overrunning clutch has failed. In a normal 1-2 upshift, the rear clutch stays on and the kickdown band applies. Here, if the transmission does not slip in breakaway low, but does slip in second, the cause is in the kickdown band and not the rear clutch. When the kickdown band slips badly or does not apply at all, the upshift will skip second completely. When this happens, the overrunning clutch holds from breakaway low until car speed is high enough for a shift to direct drive.
If there is only a slight kickdown band slip, it can cause a short upshift delay and then a thump as the kickdown band takes over from the overrunning clutch. And another thing, an engine speed flare-up during the 2-3 upshift, but no apparent slip in direct drive, can mean that the front clutch is starting to fail.
Thank you, Tech. Now, on our simplified chart, you'll see that in direct drive, both the front clutch and the rear clutch are engaged. So any slipping in direct drive can only be in the clutches. Any comments on this combination, Larry?
Well, the rear clutch is engaged in low, second, and direct. But in all forward speeds, the front clutch only engages in direct. So if low or second operate okay, but they're slipping in direct drive, the cause has to be in the front clutch, right?
Correct. And we can apply the same reasoning in the remaining selector position. In reverse, the front clutch and the low and reverse band are applied. If there's no slipping in direct, but you do get slipping in reverse, the low and reverse band is the probable cause.
Okay, Joe. I think Larry is sold on the importance of road testing. We've covered a lot of information in this segment, so let's take a few extra minutes for a review without sound. The tone arm will run in a silent groove, while our helpful record flipper operates the manual advance control for the next 9 frames.
And that takes care of road testing. What comes after that?
The next move depends on the condition, Larry. If there's an engine speed flare-up on a full throttle 3-2 kickdown, a kickdown band adjustment may be all that's needed. On the other hand, when you get slipping or engine speed flare-up during a 2-3 upshift, it may indicate that clutches or bands are failing, a condition usually caused by low system pressure.
And that's where the pressure tests get into the act.
Pressure testing is a shop operation, Larry, but you'll be able to do a more thorough Torqueflite diagnosis if you understand what the pressure tests show. When line pressure is low, the transmission slips in all forward speeds. The low pressure can result from leaky seals, low pump output, or a clogged filter. With the selector in D position, kickdown servo release pressure should follow right along with accumulator line pressure after the 2-3 upshift. Low servo release pressure can indicate a leak at the front clutch seals or at the reaction shaft support seal rings. If the tests show kickdown servo release pressure is good, you can check the low and reverse apply pressure. A leak in the low and reverse servo can cause low pressure and slipping in reverse. A sticky governor valve can make governor pressure lower or higher than normal. Low governor pressure delays or prevents upshifting. High pressure causes early or erratic upshifting and may prevent normal downshifts. Well, Larry, that's essentially what I cover in Torqueflite diagnosis. There are other clues that you'll learn to notice as you go along, but I think this is about enough for now.
Yeah, you really covered a lot of ground. That chart and the information in the service manual should help me over the humps. But to boil it all down to the basics, first you check the fluid level and condition. Second, you check the selector and the throttle linkage adjustment. Third, you road test the car, if possible, with the customer so you can identify the condition. Fourth, pressure test before the transmission is opened up.
That sums up Torqueflite diagnosis to a T, Larry. And even though we didn't get into servicing details, I'm sure everyone in the service department, and customers as well, will benefit from this session. As usual, we've added a few more hints and kinks on Torqueflite diagnosis in the reference book for this session. So be sure to read it through. And don't forget the service manual, because there's some new information there also. See you all at the next meeting.